special circumstance right here in which the common factor was, in fact, a binomial. It's something in parentheses. In this case, b minus 2. Doesn't matter. You have a common factor, undistributed, factor it out, and once you take out your common factor, you're always going to be left with a parentheses statement, because it's the distributive property you're using. All right, with the common factor? Which brings us to a second method of factoring called factoring by grouping. Now, one thing you're going to notice about factoring by grouping is it doesn't show up very often. Another thing you're going to notice about factoring by grouping is when it's required, it's just about the only way you can do it. It's just about the only way that works. So you need to get the concept down of factoring by grouping. And you need to look for the telltale signs that indicate you're going to use factoring by grouping. Let me show you the 3 examples. What do you notice about each of those examples that what do they have in common?
They have
4 terms. Did you notice that? Did you notice they have 4 terms? When you see 4 terms, the first thing that ought to come to your mind is, yeah, I wonder if we're going to do factoring by grouping. And chances are, you are. So these, the presence of the 4 terms lets you know that factoring by grouping is your best option. All right, factoring by grouping is very descriptive. Factor by grouping. I'm going to group terms. I'm going to put them in groups based on something they have in common. All right, you're going to look at these 4 terms, and you're going to put them in pairs of terms based on something they have in common. For instance, anybody want to group any 2 of these together for any particular reason?
x to the 3rd plus 3x squared.
All right, you're going to put the x to the 3rd and the 3x squared together. And you're doing that because you see they have something in common, namely...
They have a sign in the middle, like addition. They have
what do they have in common?
They have an addition sign in the middle. And in common them too? An x.
And they have more than that. What do they have?
They have an addition sign in the middle, something like that. I don't know.
What's the common factor here?
X squared.
Yeah. They both have an x squared, right? Did you notice that? You noticed that. You just didn't know what the world I was doing. All right. So, yeah, they both have an x squared. They have a common factor of x squared. Hey, the second pair, they have something in common?
6.
6, right? When I do this, I physically group them so I can remind myself, hey, I'm putting these 2 guys together mentally, and in this case, physically, visually, and I'm putting those 2 guys together. So I group them. That's why it's called factoring by grouping. Then I do exactly what we did on number 1, which is factor out a common factor. So from these 2, the common factor is
6 squared.
Factor it out. And you notice the common factor here was 6. So far, so good? And then notice what you get when you factor the common factor using factoring by grouping. You get an example that looks exactly like this guy right here. Remember that from last time? The b minus 2 they had in common. Look what you got in common. An x plus 3. So once again, I have 2 parts to my polynomial expression. Each part has an x plus 3, a binomial common factor. So I factor that guy out. So I factor once, and I factor again to get the x plus 3. Hey, I'm always going to have a parenthesis statement when I factor out an x plus 3. And my second parentheses is going to be?
X squared plus 6.
Here it is. X squared plus 6. It's only here, ladies and gentlemen, that you have factored the thing. It is factored when it is no longer stuff added, but stuff multiplied. That's when you have factored the thing. When it is factors, things multiply. All right, you see the strategy? Yes, sir?
On web design, will it matter what order you put it in?
I hope not. I hope they're not that picky. Because you know what? If you put x cubed plus 6x, I mean, those two together, and 3x squared and 18, you would get the opposite. You'd get them switched. So I hope they don't do that to you. I would have to object strenuously if they did that. So far, so good? Your strategy. Group, factor out a common factor, observe if there is a common binomial, factor it out, finish. All right, next. Please keep in mind that when we have our test, probably about 3 or 4 class periods from today, when we have our test, you will be presented with something like this, and it will say simplify or factor. And it won't say factor by grouping. It won't say factor by difference of use. It's not going to tell you how to factor. It's just going to say factor. So you're going to have to look for the keys, the clues. Hey, I got 4 terms. Bet I'm going to be doing the factoring by grouping. Be right. If you just were presented with this, and the instructions are factor, anybody got a good first step? Good first step. What's your name?
All multiples of 12.
Did you notice that? All those numbers are multiples of 12. Did we not say just shortly ago that the first thing I always try is to take out a common factor? It doesn't matter if you got 4 terms or 24 terms. If you are presented with a polynomial and you are asked to factor, the first thing you always ask is, do these terms have a common factor? And your observation is, yes, they do. You observe they have a common factor of 12. Now, most of us are not familiar with our multiples of 12 after, 4 or 5. So that's when we bring our handy-dandy calculators to determine if 72 and 108 are in fact multiples of 12, and they are. So I divide each of these by 12, and I get. One thing this does for us is it allows us to be working with smaller numbers, which I don't know about you, but that's always nice for me. Working with smaller numbers has some distinct advantages. Okay, everybody look up here for a second. Here's my new problem right there. You see it? This is just 12 times my new problem. So I'm still going to be working with 4 terms, which means I'm still going to be factoring by grouping, but with much smaller numbers. So here we go. Hey, you guys feel like being bold and daring? Maybe not putting the first 2 together? Can you handle it? Let's put the first and the third and second and fourth together. You want to try? See what happens? I tell you what. Right down the middle, you guys put the first 2 together and the last 2 together. You guys work with me. We're going to put the first and the third and the second and the fourth together. All right? And let's see. Let's reassure ourselves. We're going to get the same thing anyway. So, us group, we're going to put 2x3 plus 6x. we see they got some stuff in common. And we're going to put